Hello students, now we are learning today about the dipole moment. See, dipole moment occurs when one atom is more electronegative than other, resulting in that atom pulling more tightly on the shared pair of the electrons, or when one atom has a lone pair of electrons and the difference of the electronegativity vector points in the same way. See, one of the most common examples is the water molecule, which is made up of one oxygen atom and two hydrogen atoms. The differences in the electronegativity and the lone electrons give the oxygen a partial negative charge and each hydrogen a partial positive charge. See, here oxygen is more electronegative, that's why both of the bonding pair will be attracted towards the oxygen which is more electronegative. That's why here bond dipole is occurred. So at a hydrogen atom partial positive charge and on oxygen atom partial negative charge is formed. So overall dipole is at upper side. Next example is of CO2 molecule. See, let's look the dipole moment of carbon dioxide. The individual carbon-oxygen bond dipole moments cancel each other. The reason for it is the CO2 has a bond angle 180 degree. See, that's why both of the bond dipoles are at opposite sides. Here is opposite side and here is opposite sides. That's why overall dipole moment is a 0. Now we are taking first example. See, chloromethane. In a chloromethane, carbon atom is attached with 3 hydrogen atoms and 1 chlorine atom. Carbon is less electronegative than chlorine atom. That's why this bonding electron pair is attracted towards chlorine. That's why here the pair will be attracted towards the chlorine atom. See the second example. Methanamine. In this compound, here also nitrogen is more electronegative than carbon. That's why bonding pair is shifted towards NH2 group. Third, ammonia. In this ammonia, nitrogen is more electronegative than hydrogen. That's why all the bonding pairs, see this one and this one, all the bonding pairs will be attracted towards the nitrogen. That's why overall dipole moment will be upper side. Similarly, this is methanethiol. Another name is methyl mercaptan, which is used in LPG cylinder because of its specific smell. Here also sulfur is more electronegative, that's why pair will be shifted towards the thiol group. Next is methyl magnesium bromide. This is Grignard reagent. So magnesium is more electropositive, that's why the pair will be shifted towards the carbon atom. Okay, next is a fluoromethane, and similarly here pair will be shifted towards fluorine because of having more electronegativity. Now we are taking the dipole moment of organic compounds. See, due to differences in electronegativity, polarity develops between the two adjacent atoms in the molecule or in a bond. Dipole moment is represented by the symbol mu. Mu equals E into L, where mu is dipole moment, E is magnitude of the separated charge in electrostatic unit, and L is the internuclear distance between the two atoms, and that is the bond length in centimeter. dB is the unit of dipole moment, and the dipole moment is represented by arrow head pointing towards the positive to the negative end. Dipole moment of the compound doesn't depend only on the polarity of one, but also depends on the shape of the molecule. See, here the dipole moment is at the four sides, carbon to chlorine. Okay, next. Dipole moment of the symmetrical compound is always 0. That is mu equals 0. For example, methane, carbon tetrachloride, BF3, BH3, carbon dioxide, carbon disulfide, ethene and ethine. These molecules are symmetrical, so the dipole moment is 0. Dipole moment of the unsymmetrical compound is always greater than 0. That is H2O, H2S, CHCl3, etc. Symmetrical molecule having only one central atom. Symmetrical compounds are those compounds which fulfills the following condition. Number 1. Central atom is bonded with the same atom or groups, and central atom should have no lone pair of the electrons, like CCl4, CH4, BH3, CO2. Here, in all the compounds, central atom is attached with same types of atoms or groups. Similarly, H2O, H2S and CHCl3, these are the unsymmetrical molecules, because here electronegativity of oxygen is more, sulfur is more, and here all the atoms are not same which are attached with the carbon atom. Electronegativity of central atom or surrounding atoms present on the central atom of the molecule, which is directly proportional to the mu. Now, as we go from CHF3, CHCl3, CHBr3 and CHI3, here electronegativity is in decreasing order, so that the mu is also in decreasing order, because that dipole moment is directly proportional to the electronegativity of central atom, okay, or surrounded atoms. Next, as we go from ammonia to phosphine to arsine to stibine, electronegativity of the central atom is in decreasing order. That's why mu is also in decreasing order. In geometrical isomers, cis isomer has more mu value than the trans. Dipole moment of the trans derivative of the compound. Here carbon-carbon double bond, and both of the carbon atoms have A and B atoms. Here will only be 0 if the both A and B will be in the form of atoms. See the example. Here hydrogen atoms and halogen atoms are in a trans form, so mu is 0, but in cis form it is not 0. Here X is either Cl or Br or I or F. If the both will not be atoms, then trans may or may not be 0. Means 0 भी हो भी सकता है और नहीं भी हो सकता है. If the group has a linear moments, then the dipole moment will be 0. See, CH3, cis, then mu value is 0.33 dBi, but trans, then it is 0. If groups have non-linear moments, non-linear means here COO and C2H5, this is non-linear. That's why mu has a greater than 0 value. But trans form has also the greater than 0 value. See, here carbon-carbon double bond, A, B, C and D. There are 4 types of substituents, then mu is not 0. But if we take A, B and D, then also mu has greater than 0 value. Now we are taking dipole moment of the disubstituted benzene. There are 3 isomers of the disubstituted benzene. First is ortho isomer and bond angle is 60 degree. Second is a meta, bond angle 120, and third is a para, bond angle is 180 degree. So when the both groups X and Y are electron donating or both the groups are electron withdrawing, then the formula of overall dipole moment is under root mu1 square plus mu2 square plus 2 into mu1 mu2 cos theta, where mu1 is the dipole moment of the bond Cx, mu2 is the dipole moment of bond Cy, and theta is the angle between x and y. Next, if the values of theta will be more, then the cos theta will be less. Hence the dipole moment is as follows: ortho derivative to meta to para, mu is in decreasing order. So remember, always ortho derivative has the highest dipole moment, then meta and then para. Next, if x equals y, means both of the functional groups are same and both are atoms, then the dipole moment of para derivative is 0. If x and y are same groups and group have linear moments, then the dipole moment of para derivative is also 0. See the examples. If the one group is electron withdrawing and the another is electron donating, then the formula of overall dipole moment is under root mu1 square plus mu2 square minus 2 mu1 mu2 cos theta. See, at that time the para derivative is having the highest mu value, ortho has the lowest mu value. For example, here we are taking orthomethyl cyanobenzene, metamethyl cyanobenzene, and paramethyl cyanobenzene. See, this CH3 is an electron donating group, where CN is electron withdrawing group. Okay, so here both of the groups are different. One is electron donating, another is electron withdrawing. So at that time, mu is in increasing order. As we go from ortho to meta to para, mu will increase. Now we are taking some examples. See, this is vinyl chloride. So we know that in vinyl chloride, dipole moment will be at downward from carbon to chlorine. So mu will not be 0. In second, sulfur is more electronegative than both of the methyl groups. That's why overall dipole moment will be upward. Mu will not be 0. Next, this one is but2-ine and another is FCBr3. Here in but2-ine, linear and symmetrical arrangement is there, so that the mu will be 0. And here fluorine is more electronegative than carbon as well as bromine. That's why overall dipole moment will be upward. So mu will not be 0. Next, this one is chloroethine and another is tetrachloroethylene. See here, dipole moment will be from carbon to chlorine and mu will not be 0. And here dipole moment will be all sides of the plane. That's why planar and symmetrical molecule, and mu will be 0. Now, although the bond length is increasing, the dipole is decreasing as you move down the halogen group. So the electronegativity decreases as we move down the group. Thus, the greater influence is the electronegativity of the two atoms. So that if, see here, as we go from HF to HCl to HBr to HI, bond length increases, but electronegativity difference decreases. That's why dipole moment decreases. Now here I am giving you two examples. First is phosgene and another is fluoromethane. And now think about it and give me the answer in comment.